Today's lesson is going to be on your journal, page 52. Right after simulations, we're going to be getting into talking about independent events. These are events in probability that are independent of each other, which means they're separate. We're going to go into the notes on this, and you're going to be gluing this on page 52. So when you're done, make sure you flip to page 52 in your journal and glue there. Okay, so independent events, you should have this page that was handed to you or you've printed it off. Independent events is a compound event, and so we've talked about compound events, and we've created tree diagrams, listing method, sample space, counting principle to find how many outcomes are possible. But independent events deal with a compound event, and a compound event consists not an S there, consists of two or more events. Independent events occur if one event, and here's the key thing you need to know, does not affect the likelihood that the other event will occur. For examples, spinning a spinner, rolling a die, flipping a coin, rolling a die and then flipping a coin, drawing a card, putting it back, and then drawing another card. And so it does not affect the likelihood that the other event will occur. So to find the probability of independent events, we kind of generally follow this rule or formula. That means that if it says, what's the probability of A happening, and it uses the word and B happening, that means I want the probability of both events. And we've talked about this in general probability or simple probability when it usually uses the word or. It says A or B, and I combine the two. But in this situation, it says A and B, which means I want both events to occur. So I would have to separate the events, and I would have to do the probability of A, and then consider the probability of B. And once I get those two probabilities, I'm going to multiply. And remember, probability is a little different than just counting principle and counting how many outcomes. Probability is the fraction. It's the amount out of those total outcomes that you have, or it's a percentage, or it's a decimal. And you have to multiply those two outcomes. For example, if I spin the spinner and then I flip a coin, those are independent events of each other. Spinning the spinner does not affect flipping the coin. Flipping the coin does not affect the spinner. It says, what is the probability of spinning red and flipping tails? So I want both events to occur. So they're separate probabilities. I'm going to treat them separately. So first I'm going to find the probability of event A, which is spinning the red. So I go over to my spinner over here and I say, what is my spinning the spinner? What is my probability that I'm going to spin a red on the spinner? And so on the spinner over here, I have 1, 2, 3, 4, 5, 6, 7, 8. Some of you learned that by numbering it, you don't have to think again. It's numbered. I know there's 8, and I make sure I get that number right. So how many are red? I have a red here and a red here. I don't see any other reds. So that probability of red would be 2 out of 8. And that 2 out of 8 fraction can be reduced to 1 out of 4. Second step is to find the probability of event B, and event B was flipping tails. So I don't have a drawing of a coin here, but we know that on a coin it's either heads or tails. So my probability of tails is 1 out of 2, or one side is heads, one side is tails, so 1 tail out of 2 heads or tails choices. So the probability of B is 1/2. And again, this was the probability of me spinning a red. This was my probability of getting the tails. So my overall probability would be the product of the two events, kind of like what we did with the counting principle. So we're going to take 1/4 and we're going to multiply it by 1/2. That means I have a 1/8 chance. So basically what we just did is the probability of red and tails. And so this is how this independent event probability would look, and we would say it's 1/8. Not very good odds. 1 out of 8 is pretty low. Okay, let's take a few looks at a couple examples here. What is the probability of spinning a blue on the above spinner and flipping a heads? So we do it like this. Probability of blue, and I want heads on the coin. Independent events, two events, they don't affect each other. They're independent of one another. So I find the probability of the blue first. So the probability of blue, if you look at the spinner, I have 1, 2, 3 blues. The probability would be 3 out of 8. I'm just going to stick it right there below the word blue. And I'm going to multiply this by the probability of heads. Probability of heads is again 1 out of 2 sides on the coin. So it's 3/8 times 1/2, and I get 3/16. So my probability gets even lower and lower and lower. So the chances of two separate events that are independent happening usually tends to get smaller probability. What is the probability of rolling a die and getting an even number, and then rolling a die and getting an odd? So here's a situation where they're die. And the reason why they're independent events is because I first want to get an even, and then I want to get an odd. Before, when we said or, the word or, even or odd, it would have been all of the numbers on the die, which would be 100% or 100% probability, or 1. In this situation, they're independent events. It's two separate rollings. I roll first to see if I get an even, and then I roll to see if I get an odd, because you can't get an even and an odd on one roll. So the probability of an even is, of course, your sides are 1, 2, 3, 4, 5, 6. So 2, 4, and 6 are your evens. So that's a probability of 3 out of 6, which reduces to 1/2. And the probability of odd is the same probability, 3, 6, or 1/2. So the word and means I'm going to multiply my two. They're independent events. 1/2 times 1/2 is 1/4. So my probability of both events occurring is 1 out of 4. Question 3. You have 10 cards numbered 0 through 9. What is the probability of drawing a 1? Well, probability of getting a 1, and then I replace the card and then draw an odd number. So separate events. First event, probability of getting a 1. I put the card back. And then I want to know what the probability of me getting an odd. So in independent events, we do have to replace anything that we're taking from the event to make sure that the event has the same outcome each time. So probability of getting a 1 is 1 out of 10 possibilities. Probability of getting an odd after I replace the card back, any of the odd numbers, I'd have 1. So let's see, that's 1, 3, 5, 7, and 9. And those are all the numbers between 0 and 9 that are odd. So that's 1, 2, 3, 4, 5. So that'd be 5 out of 10 cards, or a half. So basically, I want to make sure these are in simplest form when I multiply. It makes it a little easier. But I could cross cancel if I wanted to. But what it's going to wind up being is 1/10 times 1/2, which is 1/20. So this is a 1 out of 20 odds. That's not very good odds that I'm going to spin a 1 and then do a separate event and then spin an odd number is 1 out of 20. Not very good. Next probability is the probability of spinning a green on the above spinner and then rolling a 2 on a die. Okay, so I take a look up at my spinner and I say, where are my greens? And I've been using underlines, so I'm going to go ahead and circle. So my greens are here, here, and here. And so I'm taking a look at the greens and I've got 1, 2, 3 greens. So my probability of getting green, and then it says, and rolling a 2 on a die. So green and a probability of 2. So the probability of green, I'm going to treat it separate from the probability of getting 2. Just a reminder that they're separate. The probability of getting a green was 3 out of 8. That's what we saw up here on the spinner. And the probability of rolling a 2 is 1 side out of 6. And I multiply the 2 to get my answer. And here is where I can do a little bit of cross canceling and reduce that to 1 and 2. And then top times top is 1, bottom times bottom is 16. So I have 1 in 16 chance of probability of getting a green and then a 2. Okay, so now you want to glue this into your journal on the page that we specified at the front, and we'll see you next time for our lesson on dependent events.